Hi, I'm Bob Nevis with Microtech Laboratories for Real Time with the HKPCA. And today I'm here with Tafa, who's Global Product Manager for Plated Through Holes for Atotech. Welcome.
Thank you very much.
Well, the show is winding down. Has it been a good show for you guys? I know it's been a productive show for most people.
Yeah, it was quite good. Just getting to see what's happening in the industry.
Right.
And also with the paper presentation, and also just getting to come to China, where a lot of the business is based. So it's been a good show. It's
really true. Well, I know that part of the show had a technical conference associated with it, and that you guys presented a paper on HDI via reliability. Now, your role in the plated through hole section talks a little bit about how the laser vias are prepared, getting them ready for the electroplating process. And Atotech has this new product that's specifically for high volume work. So tell us a little bit about what this process is and what you guys do with it.
Okay, so our paper was mainly concerned with the desmearing, the metallization, and the buildup of acid copper.
Okay.
And in this presentation, we were talking about a total system available from Atotech, so-called PLB copper system, with which you have a total solution for highly reliable production of HDI products.
So you're coming into the board shop basically and putting in an entire line to help them with their process from cleaning to the end.
That's true, yes. So if I may go a little bit in detail, so like for the desmear process, we have a line, the P line, so-called P line, and then we have the chemistry to go with it. And also we have people who come in to help the customer install the system. Yeah? And we work a lot in our own research labs. We work also very closely with our customers and with external institutes such as universities and so on to develop our systems to make sure they can effectively produce products with a consistent and a very good quality and yield.
People don't realize that the laser drilling process actually leaves is a somewhat inconsistent process and leaves a lot of debris sitting on the board. So, the preparation of that surface and the desmear is a very important step in the process.
Yes, this is true. So, basically, ideally, in an ideal world, we would like perfectly drilled blind microvires.
Right.
But this is not always the case, and especially with LDD becoming more or less the norm. We also have to contend with a lot of overhang problems like this. So we have to make sure our systems have very good solution exchange, and to allow the chemistry to work, to remove the debris from the blind microvires, and also to make sure we get a good wetting of the blind microvires, so that when we go to the electrolyscope process, we don't have any problems.
Well, part of it is a lot of these boards are getting thinner, and it's not, you can't just spray these hard sprayers on the surface anymore to get that kind of rotation. So I would assume that your process kind of comes about a little bit differently than the norm.
This is true. So because this is the challenge you have. You want to have an extremely good solution exchange, but you can't put high pressure pumps, right? So you have to make sure you have a system where you have good exchange without putting too much pressure on the board. This we can manage with special flooding devices, specially developed, like I said, through R&D work, a lot of R&D work. We have our own special test vehicles where we can actually measure in each blind microvire how much solution exchange is taking place. So using systems like this, we have managed to develop special flooding devices with which we can get the good solution exchange we need without applying or exerting too much pressure on the panel itself, and we can get the panel running through.
So now we've got these holes cleaned. Obviously, the next step is putting electroless copper down into these holes. So tell us a little bit about the electroless copper process that goes on.
Okay, so for the electroless copper process, we have different products, I would say. Firstly, we have the line. So we have uniplate, so-called uniplate lines coming from Atotech for the pre-treatment and the electroless copper deposition itself before you go on to the acid copper plater. And for different applications, I would say we have basically two families of products. The first family being, and the differentiation is mainly depending on the type of base material you have. So for the more advanced laminates, we have a specially developed process where, because normally these are getting smoother,
right,
to make sure you have no problems with blistering.
Things don't like to stick to those.
Exactly,
as well,
exactly. So we have specially developed electroless copper processes with favorable, I'll call them favorable stress characteristics to make sure it sticks, right, to the surface with no blistering and so on. At the same time, we also want to have a good throw into the blind microbias, a good throwing power. Right. This is also not a function of the chemistry itself, but you need a good cooperation, I'll call it, between the chemistry and the equipment.
Yeah, the equipment.
Which is also an advantage of the systems approach.
Now, the electroless process is also a very, uses a lot of chemicals and has to be kept at a very close level. How does your process monitor that, and is it beneficial? Are you reducing the amount of chemicals going in, or what's different about it?
So we have what's called the VCS, Visual Control System, where we have a computer, which with this computer, together with now new automatic control units, you can measure for almost every process step the chemistry in time. So it means
keeps the chemistry consistent.
Exactly. So you constantly measure it, you keep it consistent, and you can automatically correct. So we have really a complete system also for the monitoring to make sure you get a consistent quality and a good quality and high yield.
Consistency is definitely the key with this.
That's true.
Because over a large panel and all these holes, you want to make as consistent a hole as possible.
Exactly.
Great. Well, thanks a lot for your time. We do appreciate you taking the effort to tell us a little bit about what's going on here.
Thank you very much.
You're welcome. And for Real Time with the HKPCA, I'm Bob Nevis.